Hello dear students, this is the continuation of classes which we are doing. In today's topic I would like to discuss about weight. So what is weight? Actually the weight word has been used in a very different sense in our day-to-day life. If somebody will ask me what is my weight, then I will say I am 50 kg. Now 50 kg, you need to understand 50 kg is not my weight, 50 kg is my mass. So what is the difference between weight and mass? What is weight? So these are the topics we are going to discuss today. Weight of a body is the force of gravity acting on the body. So what does it mean? It means that I am a mass, I am attracted by the earth towards the center. So if I am attracted by the earth towards the center, what is the force of the attraction acting on me? That force of attraction is my weight. So we have a formula to calculate the weight of a body. So let us derive that formula. This is the earth. Suppose the mass of the earth is m, the radius of the earth is capital R. There is a small body of mass m in the surface of the earth. Now I am going to calculate the weight of this mass. According to Newton's law of gravitation, this small m is attracted by the earth towards the center. So the force of attraction can be given by this formula. So we can say this force is the effect of gravity upon this mass, and according to the definition, the effect of gravity upon a mass is the weight of the mass. So by the definition of force, I can say force F is equal to weight of m, and we know weight is represented by W, so I am going to write W for F. So it becomes G capital M small m over R square, and we all know G capital M by R square. This is acceleration due to gravity on the surface of the earth, and we represent acceleration due to gravity on the surface of the earth by G. Means my whole relation will reduce to mg. So I can say weight is mass times acceleration due to gravity. So now let me answer the first question which was raised in the starting of this video. What is my weight? So I answered my weight is 50 kg, but actually I was wrong. I was not giving the answer of my weight, rather I was giving the answer of my mass. So if my mass is 50 kg, then what is my weight? So in order to find my weight, I should know what is acceleration due to gravity on the surface of the earth. And we know acceleration due to gravity is approximately 9.8 meter per second square. So 50 into 9.8 will be something around it is approximately 500 Newton. Kg, let me simplify here, it is kg meter per second square, and it is 500 kg meter per second square is Newton. So my weight is 500 Newton. So you can see I am attracted by the earth by the force of approximately 500 Newton. So that is the weight, my weight, if my mass is 50 kg. So with the help of this formula, W is equal to mg, now we can calculate the weight of any body. What are the factors upon which weight depends? So definitely from this formula we can see it depends upon the mass of the body, and another it depends upon acceleration due to gravity. These are the two factors upon which weight of a body depend. Now mass of a body is a constant. The mass of a body is not going to change, but acceleration due to gravity changes. So I can say weight is directly proportional to acceleration due to gravity. And moreover I can say what are the factors which affect acceleration due to gravity? Same factors are going to affect the weight of the body. Acceleration due to gravity at the center of the earth is zero. This yesterday in my video I have derived acceleration due to gravity at the center of the earth. So if acceleration due to gravity at the center of the earth is 0, then definitely weight of a body at the center of the earth is also going to be 0. So now this is a very interesting situation. If a body is taken to the center of the earth, then that body will have mass, but that body does not have weight. So what is this situation called? The body has mass, mass is present, there is the presence of mass, but no weight. This is a very interesting situation. So when a body has mass but it does not have weight, then this situation is called weightlessness. So when does this situation arises? There are some conditions, and those conditions we are going to discuss. One condition I have already stated, at the center of the earth. Similarly, the other situations are in the outer space. If a mass is taken to the outer space, there are no any heavenly bodies to exert the force of gravity upon that mass. So in that regard, the weight of the body becomes 0. Similarly, during free fall. So what do you mean by free fall? Free fall means if a body is falling only under the influence of gravity, if no other forces are acting on the body and body is falling only under the influence of gravity, then at that time the weight of the body becomes 0. So why? Definitely a question arises, but this is a very good topic for another video. In another video I will explain why the weight of a body becomes 0 during free fall. But now here you understand, during free fall the weight of a body becomes 0. And another is at the null point. So what does it mean? Null point means, take for example, there are two heavenly bodies. This is a heavenly body, A heavenly body. This is another heavenly body, that is B. Now there is somewhere in between where the gravitational field of these two bodies are equal and opposite. So at this point, if you keep a mass, this mass is neither attracted by this body nor it is attracted by this body. Or you can say the gravitational influence of both the bodies in this mass is cancelled out. So this point is called null point, and if a mass happen to be in this null point, it is not going to feel the effect of gravity at that time. It becomes weightless. So in the outer space, during free fall, in the null point, and I have already told you at the center of the earth. So these are the cases in which the weight of a body becomes 0, or we can say a body becomes weightless. So after this discussion, now I would like to add a little bit point. This difference I would like to state. Mass is the total quantity of matter contained in the body. So actually it depends upon the number of atoms present in a body. But weight is force of gravity acting on a body. Acting on a body. The SI unit of mass is kg. The SI unit of weight is Newton. Mass is a scalar quantity. Weight is a vector quantity. Mass is constant. Since weight depends upon acceleration due to gravity, weight is a variable. And moreover, mass is measured by beam balance. And weight is measured by spring balance. So these are the differences between mass and weight. So at the conclusion of this video, I would like to say that today we learned what is the definition of weight. We derived the formula to calculate weight of body on the surface of the earth. We came to know that weight is a variable quantity, and we also came to know that the factors upon which acceleration due to gravity depend. In the same factor, the weight of a body also depends, and we came to know that there are some peculiar situations when the mass will have no weight. So that is called weightlessness, and we have stated the condition in which a mass can become weightless in the outer space, during free fall, at the null point, at the center of the earth. So these are the cases when the mass will have no weight, or we can say mass become weightless. And similarly, we have stated the difference between mass and weight. This much for today. For further information, please contact. Thank you.